Hey folks, how's it going? This is Rob coming to you with a little video on homework quiz number 3, Math 134. Okay, so in this video I'm going to go ahead and talk to you about how this quiz went down, some stuff you need to know, and hopefully answer any lingering questions you might have. This video, or rather this quiz, was intended to cover sections 9.8 and through 10.1. It did, however, have a strong emphasis on 9.8. As both of the questions are financial related questions. I put a heavy emphasis on this because it's going to come back later on, including most likely on some tests that you might be taking in the future. Hint, hint. So hopefully you find this video to be helpful to you. Okay, so our first question is, custom office makes a line of senior executive desks. It's estimated that the total cost for making X units of their senior executive model is given by the function C of X is equal to 100X plus 200K. All right, so what we need to know is what's the average cost and marginal cost functions. Okay, so what this means is essentially if I make X number of units, this is the total cost. So right, we have this broken down into what we call our fixed costs. Right, we're gonna pay 200K no matter what. Right, we got to turn on the lights, we got to pay rent, etc. And then we have what we call our variable costs, right? So the more units we make, the more we have to pay to store them, the more we have to pay people to work to make them, the more we have to pay certain costs for materials, because obviously more things being produced means more materials, etc. Okay, so to find the average cost function, we need to remember that the average cost function it's an average. So it's the cost of producing the items out of the number of items you produced. Because what this does is it says, hey, let's say that this item, or that we made X number of items, right? How much on average is each of these costing to churn out? Because what you got to think about is, even though we do have these variable costs, the fixed costs are also divided among the amount that we make. So here's an example. Let's say that I make one senior executive model desk, and this is 100, right? So what I have is 200,000, 100. So this is one desk. Okay, if I have two desks, right, it's going to cost me this. So on average, each of the desks is going to cost me 100,000, 100 to make, right? If you split it up evenly. If I make 3 desks, it's going to be like this, right? So to figure it out, I'd have to cut it into 3 equal parts, then 4 equal parts, etc., up until X equal parts. So if we look at it in terms of this function, what we have is 100X plus 200,000 out of X. For full credit, I do want you to simplify this, so we should get a final answer of 100 plus 200,000 out of X. I was picky about that, especially because this was helpful for figuring out the derivative. Okay, so this is the cost, the average cost function. Okay, the cost essentially on average per unit produced. Now, not every model is going to cost this much, right? It's a naive assumption, right? So some days my workers might not be productive, so the labor costs are going to be higher. Maybe other days they're super productive, so the labor costs are going to be lower, but they're going to average out to this costs. Okay, to find the marginal average cost function, as the notation indicates, you need to find the derivative of the cost function. In other words, the derivative of 100 plus 200,000 out of X. Okay, so if we're going to find this, we're going to go ahead and use the sum rule. So this goes away because the derivative of a constant is nothing. And so here we could look at this as a quotient rule if we really wanted to. So we could have low D high minus high D low over the bottom squared. Okay, so in this case, the derivative of 200,000 is 0. The derivative of X is 1. So what we get is we get negative 200,000 over x is equal to the marginal cost function. Okay, so essentially what this means is that at any given time, the average cost of producing these desks is decreasing by 200,000 over x. Let me give you an example. At 2, the average cost is decreasing by 100,000, right? Think about that, right? Because if x is 2, negative 200,000 over 2, right? Let me just show you so you can see. So look, if x is 2, right, then the average cost, the marginal average cost, right, is negative 200,000 over 2, which is negative 100,000, right? We can see when we get to this number 2 that notice the difference here between 1 to 2 is $100,000 less per unit. Okay, so again, we have our average cost function and its derivative, our marginal average cost function. You did not have to get the derivative this way. You could have also noted that this is just 200,000 times x to the negative 1. So then the derivative using the power rule would be this to the minus 2, which then would get you there as well. Sorry, let me just make sure I noted this has to be an x squared, okay? Not an x and x squared, okay? So please make sure you understand how I did that. So then actually this changes a lot of things. This will actually make this 4. So then it's going down, it's decreasing by 50,000 at that point in time. But notice, it's as we continue down, if I was to take 200,300, right, and I was to divide that by 3, 200,300 and divide it by 3, what I get is 67,766.67. So we can see the difference here is about 30 to 40K. So we can see that I'm really starting to decline at about that point. Okay, so hopefully this made sense to you. I wouldn't worry so much as interpreting right now at this point, as much as making sure you can understand, one, how to find the average cost and how to find its derivative, the marginal average cost. So please make sure you understood what I did here, and then in a moment I'll move on to the second problem. Okay, so the second and third problem went together, and this had to do with the demand for a pulsar 25 color LED is given by this function where P denotes the wholesale unit price and X denotes the quantity demanded. The cost function is given below, and we're going to be asked to give out 2 pieces of information, the revenue and the profit, and then we're going to be asked for the marginal profit, which is the derivative of the profit. The tricky thing here that I didn't get is some people got your profit and your revenue mixed around, so be careful there. So here's what we know. We know we have a certain number of units, X, and X units are being produced and sold at this given price. So in other words, each one that is being sold for this price. So let's say that I am selling 10 of these things, right? Then X is equal to 10. This is equal to 50 cents. So every one of them is selling for $599.50. If X is equal to, how about I make it even nicer? What if X is equal to 100? If X is 100, then this is 5. So in other words, every one of them is being produced and sold for $595, assuming that we're selling 100. Now, how much money are we going to make if we sell 595 100 TVs for $595? We're going to make 595 times $100, right? The amount you sold it for times the number you sold. Okay, if we continue on, what if this was 1,000? Well, if X was equal to 1,000, then this would be 1, 2, we would have 600 minus 50, which is $550. So let's say that I had $550 that I was selling them for, and I sold 1,000. This would be my revenue, right? I take the number that I sold and multiply it times the amount each one was sold for, right? And that makes sense if you think about it, right? Because I'm talking about the total that I'm bringing in, and the total that I'm bringing in is equal to the number of things that I've sold times what I sold them for, assuming in this case they're all the same. So in general, what this means, sorry for that random like splotch there. In general, what this means is that the revenue function is equal to the price times the quantity sold. Okay, so if I'm going to do R of X, what I'm going to do is I'm going to take the price times the quantity. And the price is 600 minus 0.05x, and the quantity is x. And so distributing that in, I get the R of x is equal to 600 x minus 5/100 x squared. Or you could have this the other way around. So the other way you could write this, or, is x squared plus 600x. That's the other way you could do it. Either one of these are mathematically equivalent, so they'd be the same. Now profit, well, we know how much are we making in profit. So if I want to know my profit, I'm going to take the total amount of money that I raised, my revenue, and subtract it by what it cost me, right, to make that revenue. So what I'm doing is, if I want my profit, I'm taking my revenue, so I'm going to write it in standard form. 5/100 x squared plus 600x, and I'm going to subtract what it cost me to make those units. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 2 x cubed. Now, here I'm subtracting a negative, so plus 3/100 x squared minus 400x minus 80,000. Now remember the example we talked about in class. This makes sense because what this tells me is that if I produce and sell 0 things, so x is 0, then what I lose is $80,000. And that makes sense. If you make nothing, not only do you make no money, but then also you lose what it cost you, right? Okay, so what I'm going to do is I'm going to combine like terms here, and what I should get is, let's start with our leading term, 1, 2, 3, 4, 5, 2x cubed. Okay, I had to double count that for a second. Now my x squareds, so what I should get is minus, because I have a minus 0.05 plus a 0.03, so just get a minus 0.2 x squared. All right, and now what I'm going to do is I'm going to do, so I have 600 and 400, so plus 200x minus 80,000. That is my profit function, okay? So what this tells me, and I'll move that in a second. What this tells me is that if I produce and sell X number of things, this is the total profit I'm going to make. And so where we're going with this is the marginal profit function. So I've got the marginal profit function, and that's I'm going to find by using the power rule and a sum rule, or difference rule, I guess. So I here bring the power down. I get 1, 2, 3, 4, 5, 6 x squared minus 4/10 x, 4/100 x plus 200. And so where we're going with this is, well, if I can figure out what makes this derivative 0, what that allows me to do somewhere between 0 and 12,000 is potentially find the number of things I need to sell that will maximize this profit. So we're going to continue to take this forward, and that's why understanding the economics applications is so important. And so especially in a class like this, Math 134, I'm going to push those applications when we get to the homework quiz. I hope this is something to think about as we get into the next set of applications when you think about what am I going to give you on that homework quiz, okay? So I hope you found this to be informational. I hope this video was helpful to you. Again, this is our marginal profit function. Please keep the questions coming. You can email me anytime, pictures of your work at robert.moray@umb.edu. Send me your work with pictures and questions so I can help you. And remember, you can do it, okay? Thanks so much for watching. I hope you enjoyed this. Don't forget to like or subscribe so you can stay up to date when I post my videos. And don't forget to love math. Have a wonderful day.